Hi, everyone. This is Bobby Harris, the Executive Director of the Utility Broadband Alliance. We're going to let all of the attendees get logged in just a moment. Takes just a moment sometimes for all of the connections to happen. We are fortunate today to have a fabulous cybersecurity focused webinar, a technical webinar really to share best practices. We are recording this session as always. For those of you who are in attendees, as the recording said, you're in listen only mode, but you'll notice there's a small questions tab on your tool chart there where you can type in your questions for the panel. We'll do our best to get to everyone's questions at the end of the webinar. If we don't get to yours, we will follow up after the webinar, but we'll do our very best to get to those. And it looks like everybody's gotten logged in now, so it's my pleasure to turn this over to Craig Watson from Worldwide Technologies. Craig's going to take us through the program and introduce everyone. And Craig, I'll be back with you at the end to do the Q&A. It's all yours, sir.
Very good. Thanks, Bobby. Happy Halloween to everybody. I promise no tricks, only treats this time around. As you can see, I don't think any of us decided to dress up today, but we're more than happy to kind of go through this discussion as it relates to securing private cellular networks. Going through what we'll be reviewing and talking about today, quick introductions on who we are, where we're working, the different things that we do in our daily lives. We'll talk about some of the deployment models and how those impact security as different organizations, utility companies are looking at deploying private LTE into their own infrastructure. Mike's going to cover some securing the fundamental components, talking about the core, the backhaul, the RAN, the UEs, and NMSs. We'll have a quick review of secure remote access, what that means, why that's important, and some of the various different options that are out there. We'll also give a high-level, review of some zero trust architecture, really kind of some methods, models around what should be looked at and how you can provide this type of security architecture for your private LTE environment. And then we'll close out with Eric Evans from Evergy, who'll give kind of his viewpoint as he's been with us through this process and what they've had to look at from a security point of view, and being able to make the the processes, the procedures, and really a lot of the integrations into their own environment. So, as Bobby said, I'm Craig Watson. I'm a Utility Client Executive at Worldwide Technology. 20+ years of working in IT, OT environment, networking, security, telecommunications, and it's my pleasure to kind of lead and facilitate the discussion today. Joining us, we have Mike Robinson, Solutions Architect at Worldwide Technology. Mike comes with a long history of working for a utility, working within the manufacturer OEM environment. I'm sure many of you know that he spent many years at Cisco. And then Eric Evans, who is our principal cybersecurity architect at Evergy. Happy to have him join us and share his thoughts as we kind of look at really, again, more of what they've implemented and put into their own infrastructure and environment there within Evergy. We'll definitely open up at the end some Q&A to answer any questions that might be there. So kind of starting out, some of the different deployment models, and again, how this is really impacting security. What's really happening is as the evolution of these infrastructures are being put in place, we have to look at how security needs to change along with that. So many different ways of looking at the various different coverage models. When you look at the private versus core as a service, meaning you're hosting it or having it hosted by somebody else, having a centralized core versus a distributed core, and having the difference of what's in a central place versus in multiple different locations for resiliency, redundancy. Looking at the private versus virtual versus a shared RAN network model. So how you're actually getting that connectivity and that spectrum out there into your environment. Of course, you have the private versus shared spectrum methodologies that you need to look at. The private versus public backhaul is another area that needs to be figured out and talked about. We have in-house versus outsource versus managed services for how you're going to support, take care of, and really administer the environment itself. And of course, all these administrative services that have to be thought of as we're looking at the different types of coverages, as well as what we can do in the various different phases as we roll them out to really kind of meet that full service territory. Mike, was there anything that you wanted to add here?
Let me make 2 quick points, Craig. First of all, as utilities think about their private LTE strategies and different models and things like that, over the course of time, things are going to change. And probably the 2, I guess, hidden things, or maybe hard to think about things, is number 1, the migration from a centralized architecture where you got the core. It's basically serving everything throughout the entire territory. As utilities adopt distribution automation and put that over their LTE systems to achieve that low latency, they're going to need to distribute the core into multiple locations. And when we're going to see in a future slide that trusted environment now is no longer in one place, it's in multiple places. And then the second thing is, as utilities think about the backhaul that gets the connectivity out to the eNode Bs, it's not always going to be on their private fiber infrastructure and private microwave. At times, they might need to utilize third-party services for that connectivity. So those are 2 things that we might forget about as time goes on. And when you think about security, you got to think about how that's changing.
Yeah, definitely good points and things to kind of think about as we move through some of this and look at some different models. Speaking of, some of the various different network operating models that we've seen, kind of from that left to right operational model, where again, the utility normally today has a public service provider who has not quite moved into that private LTE environment. But I know there's many different options here as we move over into that full private LTE, private wireless environment. That I think, Mike, you've got some thoughts and opinions here on what is kind of the best approach and how utilities can start stepping into this type of various different models and phases that we've discussed previously.
Yeah, and these models basically depict, as you can imagine, different configurations that are maybe better for one utility and not so great for another utility. So it really depends on their context of operation and what their goals are. I've worked with some utilities that want to work towards that total blue network where everything is theirs. And I've worked with other utilities that aren't ready to make that leap, but they do want to get into private LTE. And one of the ways to get there is to adopt what's called a roaming strategy or a PVNO strategy. But regardless, these 6 different variations are not the only 6. They're probably the ones that are most discussed at this point in time. I think over time, we'll see different variations come. And again, when those different variations come, it creates new challenges that a security architect needs to kind of work through and understand what's changed so that they can come up with the appropriate security architecture for that particular operating model.
And Eric, I know you at Evergy, you went with the full utility-owned private LTE network where you own the core, you own the RAN, the business is going to own the UEs, but that environment is really kind of owned end to end there. Anything that you want to share while we're kind of talking about that in the decision-making process, or is just this kind of natural progression that you had yourself?
I think it was more of a natural progression. Evergy is in a unique situation where we own a lot of that backhaul infrastructure already, whether that's fiber or microwave technology. So having and being in that kind of situation, it kind of helps us get to the preferred model a little quicker.
Yep. Nope, very good. But as we kind of move into some of these security considerations for some of these components, I was going to have Mike really kind of talk a little bit more about some of these different elements, some of the different components, and really kind of the importance around them. So Mike, I'll turn it over to you as we kind of go and look at some of these various different areas here.
All right, thanks, Craig. So what I'll do is I'll kind of work us through what are some of the major building blocks of the LTE or 4G and 5G architectures. They're covered under the 3GPP guidance. And so that's a great place to go and learn about what those components are. And I'm just going to hit the high level. You can certainly dive deep into each one of those subcomponents. The first thing to think about is the EPC, or the Evolve Packet Core. And when we think about security on an EPC, it's important for us to think that that EPC is built upon just common compute systems. And so we can think about what security mechanisms might I have for common compute? How safe is that compute? And so, there's some aspects there. And then on top of that, you can have like some virtualization software, whether it's running VMs or containers. There's a layer there that needs to be thought about. And then upon those containers or layers, we have the different 4G functions. And throughout this discussion, I'm going to predominantly talk about 4G, although it's also important to think about 5G as well. But our terminology for today is going to be in 4G. But you have those 4G functions, and then we can't stop there with the core. We even need to think about how some APIs might be interfacing that core, and you might have some systems from third parties that's there. And so thinking about the security of the EPC involves all of those things. Next, we have the backhaul. And for a lot of utilities, they have MPLS networks. Some utilities, as we know, are making the migration to segment routing. And even SD-WAN is a great option for thinking about the backhaul between the core and the eNode Bs. And how one secures that backhaul is important to kind of work through. And then I mentioned the eNode Bs. That lives in the RAN, the radio access segment. And even the radio access network is being split up into sub-functions where you have the CU, DU, and those can be interconnected with what's called front haul and mid haul. And so we don't have just like one thing anymore to kind of put a perimeter around. We have to think about its sub-functions. And then beyond that would be the user equipment. You might call it the device, the router on the pole, whatever. And so we're going to really dive into that and kind of understand how to think about the security environment for UEs later on in this presentation. And then coming back to the core, we'll have where the information goes out to SCADA systems, our head ends. It might go to an AMI head end and other different kinds of systems that would be referred to as the PDN or the packet data network. That's really referring to the applications that you're supporting up at the control center, data center, and this sort of a thing. But there's also the integration of roaming interconnections. You know, a couple of years ago, utilities weren't thinking a lot about roaming, thinking that their private LTE system would be kind of like a self-contained unit. But as we saw at the latest Plugfest, that roaming is very important. And so we need to secure that interface as well. Before we move off this slide, I just want to point out that from a 3GPP perspective, that core environment is thought of as a trusted environment. Everything to the right, the connections out to the PDN, untrusted. Everything to the left of the core, including that backhaul, that private fiber, is considered from a 3GPP perspective as an untrusted environment. And there's reasons behind that. So that just kind of helps to start with a framework of how to think about the private LTE system. So now let's go to the next slide and dig a little deeper. As one thinks about the 3GPP environment, there's so many things to think about from a security perspective. And a great resource is this NIST document. There are other resources that you can go to as well. I've personally found that this is a great resource that helps you dig into all the different sub elements and sub aspects of the private LTE environment. And NIST categorizes security into those things that's listed on the left-hand side. I do want to call out, before we go too far, that within the core environment, you'll see those 5 subcategories. The HSS is one of the subsystems that keeps track of who is valid to be authenticated onto the system. And so that winds up being a very important security subfunction. We're going to get into that more in a little bit, but I just want to call it out right now that in the HSS, the keys to the kingdom are in there, okay? And it's a very important subfunction within the core. Let's go ahead and go to the next slide. Now, within the 3GPP architecture, it's good to be aware that there are mandatory protection things and there are some optional protection things. And when you get your private LTE system built, it's important to be aware that you'll need to make the decision when things are optional. Do you want the vendor who's building your system to enable those things or to turn some things on, or do you want to leave them maybe off? And there's reasons why you might want the latter, oddly enough. But on the left-hand side of this slide, I do want to call out that there are data flows where the 3GPP architecture actually says there is no integrity protection. See that red circle around the word no. And so be aware of that, okay? On the right-hand side of the slide, there are some different flows where, for example, at the signaling layer, there is an optional encryption. You can either turn it on or you can leave it turned off. And unless you specify, it might be left off, but in your thinking, you might think that it's turned on. that's one of those things that you'll just want to make for sure that you work with your equipment provider to say, hey, no, that one I definitely won't turn down. And then working down later within the actual data flows itself, encryption is optional, and so you'll need to decide whether you want to turn that on or leave it off. And some service providers don't necessarily turn that on because they feel that it's the obligation of the user if they want to protect that traffic as it goes across the LTE network. Well, for utility, you're both the operator and the user. Now, it might be your AMI department, your distribution automation department, but it's still you. And so you'll need to kind of think about security from the context of you as the system operator and you as the end user. So let's go to the next slide there. At this point, the previous slides were really talking about the security of protecting the integrity of the system itself. And now we want to transition a little bit and talk about how we would secure the information that's flowing over that system. And one of the most important things to be aware of is the importance of the SIM. The importance of the SIM. And in this slide, I show 4 different configurations. Again, there's a lot more than this, but these are kind of widely thought about. On the left-hand side, we see the device. I'm gonna call it the router on the pole, and it has, in this instance, a service provider SIM in it. That's what most utilities have right now. Is they have a router on a pole and they've got a SIM from one of the carriers, okay? And when they do that, the traffic that comes across that network would terminate on the carrier's equipment and then be extended into the utility's environment. However, when a utility deploys private LTE, then they have their private SIM, okay? And that private SIM, as we're going to see in the next slide, contains some secret and some sacred data, okay? Secret and sacred data. Now, in that second column there, we have the two SIM configuration where one's a private SIM, which might refer back to, like whatever frequency you've got your radios on. And then you also might have a roaming SIM. And in this example, that roaming SIM would bring that traffic all the way back to your core. In the third column there, we got a situation where we have 2 different radios and we have SIMs associated with the different radios. And how that security architecture looks is a little bit different than those other models. And then lastly on this slide, we have the notion of an embedded SIM. Now, in the first 3, those were physical SIMs that could be taken out of the unit, but this one winds up being embedded on the equipment itself, okay? And that has a different security profile as well. So the point here is that there are different configurations of whose SIM, how many SIMs there might be, and who controls those SIMs. And so those are different variations, and the security architect just needs to kind of work through, from a security perspective, what's going on in those different models. Let's go to the next slide.
Hey, Mike, I would just chime in too. I think this is definitely an area where we were very concerned at first and still are. I think the SIM strategy is something that needs to be thought about very carefully. Just the different types of SIMs. Once you start meeting with those companies like G&D that will be burning SIMs for you, you know, being able to securely transfer keys. What do those internal processes, chain of custody for physical SIMs look like, right? Trying to prevent rogue devices on the network. This is an extremely important area that anybody in security should definitely think about, because as you start to have those meetings, you know, with those companies that will build up the profiles, and you might be setting up over-the-air connections and VPNs back to these guys. There's quite a lot there that at least for us, we weren't aware of because we don't have the traditional cellular background. So this is definitely something that I think needs to be thought about sooner than later, because definitely an avenue of attack would be rogue devices. So these are all details that organizations definitely need to think about and choose wisely on, you know, what your SIM strategy is going to be. I mean, this was something that we didn't really think about at Evergy a lot on the security side until we met with WWT and started to talk through some of these things. But just wanted to bring up for those of you, you know, on the information security side, don't neglect your SIM strategy.
Very good. Thanks for that addition, Eric. And I just want to underscore what he just said there. In the past, that red SIM was someone else's responsibility. Now, in a private system, it's your responsibility. And as he said, think about it early, because you do not want to redispatch out to all those poles that are going to have devices with SIMs in them. Okay, on this particular slide, I'm not going to go into all the details there, but rather what I want to do is I want to basically say the SIM is the mechanism by which you are known so that you can join the network. And if we work over here, we're going to make an analogy between the mobile equipment on the left-hand side and someone saying, I am this person and I'm trying to prove that. On the left-hand side, you've got the mobile equipment, and inside that equipment, it's got what's called an IMEI, which is basically a unique number, like a serial number, that's burnt into that device, okay? It also has a SIM card in there, also known as a UICC. And that SIM card inside it has another unique number. And a lot of operators will want to tie those numbers together so that if someone were to steal that SIM and put it in another device, when it registers and tries to get onto the network, it'll say, well, it's no longer in that original device. The analogy on the right-hand side is if I said, this is who I am, then you could take a fingerprint, that's that IMEI, and then I could also show you my driver's license, where you would have to know what state issued that driver's license, then look at the number associated with it. And then lastly, deep inside that SIM, there's the K value, which is the secret by which I am authenticated by, because I have been given access to this particular network. Okay, so a lot of information is on that SIM. Let's go to the next slide there, Craig. Okay, on this particular slide, rather than go through all the details on the left-hand side, which the reader can kind of work through, I just want to point out that as you develop your UE strategy, your device strategy, you need to think about a lot of different things from a security perspective, because that's how your traffic is going to be able to join the network and then send information across the network. And as you work through that, be cognizant of the fact that that device is going to be on the pole for the next 15 years. And you might want to make changes on it. And so when you're making those changes, there's a security aspect that's tied to that. Let's see. Anything else you want to make a comment on, Craig or Eric there?
Yeah, the two things I was going to highlight, and these are kind of conversations that have come up with other utilities, especially within their own security policy of what they allow and don't allow. One of those interesting things are the applets. Basically the ability to have that, whether there's a physical SIM today that might move into an eSIM or an iSIM in the future, that SIM itself can be programmed or can be communicated or connected with using Java. And Java is a very, again, different security groups have different policies regarding the use of Java within their infrastructure. Sometimes it's allowed, sometimes it's not at all. And there's no way to enable that. So those type of things, knowing what your security policy within the organization, what the security team and group has in relation to some of these things will, impact how you're able to program or even reprogram or enable certain features on that SIM through what is allowed from your own internal organization. And the other thing I want to talk about is the trusted platform module. I'm a big proponent. I like this idea of being able to include a hardened chip that is within the UE that really allows for the ability to lock down and secure and ensure that no changes can be made to the inherent code. Those are certain things that as you develop a UE strategy, as you look at what is available out there on the market, look at those that have either the ability to provide and have a TPM chip today, or are going to be able to have this soldered on into their gateway so that you have some more trust, you have that security enabled on the device itself. So those are the two things I wanted to call out. Eric, anything from your perspective?
Well, I think anybody that works in information security, anytime they hear the word Java, spidey senses go up. So, definitely, I know that when we started meeting, with the company that is going to be burning our SIMs, and they started talking about the different types of profiles and the provisioning profile, and they started talking about Java applets, we all were just kind of like, what? There's Java applets on these things? We just thought there was a bunch of XML files or text files burned onto these things. So it definitely could be, an attack surface. If, like I said before, if you don't have that SIM strategy done right, it's definitely something you need to think about. Yeah, hardening these things. It's just like we harden servers on the corporate side, right? So it's just a whole nother thing that you have to account for, and definitely have to rely on your partners to educate you on, hey, you might want to think about some of these things, as you come up with your PLTE strategy, just like you guys did for us.
Yep, exactly.
Thanks for that, Eric. And then I'll just add one more comment, Craig, before we move on. And that's back on the containers and applets that might be on the router itself. Heretofore, as an industry, we haven't seen a lot of that. However, going forward, I think we're going to see a lot more need for distributing applets down toward the edge of our network, and that means down to the UE itself, okay? And when you do that, and you have those applets running there, it really introduces a lot of different things from a security perspective. Remember, that applet is running, it's running on some form of container that needs secured, and it's running on some sort of hardware that needs to be secured as well. So really delve into the UE, whether it's the SIM as we've been talking about, the UE and all of its mechanisms, to understand from a security perspective what are all the issues that you'll need to kind of work through as you develop your security architecture. Okay, and with that we can go to the next slide. On this particular slide, remember that we talked earlier about the fact that the HSS was a very important security function. Inside the HSS is this notion of the K value. And from that K value, which by the way, you need to keep an absolute secret. However, that K value gets put on, as you can see, the SIM on the left-hand side here, and you've got not only thousands, but tens of thousands. And whenever AMI 2.0 gets here, it's going to be in the millions of devices. And so maintaining a security posture around, as Eric was mentioning, even how you facilitate getting those SIMs created and how you facilitate getting changes worked through over the air and that sort of thing is very important. But back to this slide here, from that K value, the private LTE system will create sub keys, and those sub keys will be unique for the MME, which is a part of the core, the eNode B, which is part of the RAN, and the UE, which is the device out on the end. And so even though we start with the K value in 2 locations, from it will be created numerous different keys along the way. And also through the course of the day, the week, month, whatever, those keys will need to be changed out so that if someone is able to find that K value, that its shelf life, so to speak, will be short enough so that it'll be changed and it'll be, hard to attack the system. So there's a tremendous amount of security mechanisms that's built into the private LTE system, which is one of the reasons why it is so strategic and so valuable from a utility standpoint as it does grid modernization, to depend on a technology that's just rich and as we go from 4G to 5G, 5G to 6G, those mechanisms are made richer with every variant, okay? And so this slide tries to depict, some of the mechanisms there that are built into the 3GPP architecture. All right.
Eric, I do have to put you on the spot here. How many times did we actually talk about how special the K was before you figured out that we weren't talking about the breakfast cereal, but we were talking about this K value?
The first time you guys brought it up, I think it sunk in, and that it's definitely something that, you have to think about how are these keys generated, where are these keys stored, how do you transport the keys, like I was saying before, to those providers that are going to burn the SIMs, but then also all of these LTE core components that are listed on this slide, who has access to those things, which is something I know you're going to get into in the following slide, right? So all of these little pieces of, the LTE puzzle are things that people in security really need to start thinking about, even to the point where we had one of our developers on the radio team who are building out scripts to help get these SIM profiles built. That's getting stored in a repository. Even though it's a private repository, you have to make sure that there are not secrets and sensitive information that makes its way into that repository. These are all kinds of things. From a, sec dev perspective, you think about this thing on the corporate side, right? Because we all have developers, we all, you have either commercial off-the-shelf applications, maybe some homegrown apps. So you think about that from a development perspective on that side, right, of the network, the corp side. When it comes to PLTE, there's some similarities and similar things that you have to account for as well. But yeah, first time you guys mentioned the K value, and especially the HSS with the keys to the kingdom, I mean, that automatically moves those things to the top of the list of how do we secure them.
Yep, Special K, it's not just for breakfast anymore. So, no, great points. Thanks, Mike. Thanks, Eric. Moving on here, I want to talk a little bit about the importance of secure remote access, especially for private LTE administration. I know a number of utilities already have secure remote access in their environments today. One of the things that definitely needs to be thought of, and as we go through and look at either the vendors, your managed service providers, your own users, the support staff, the contractors, how are you going to enable and provide inbound remote access for many of these different types of support organizations? These are all kind of challenges as we look at, because again, as Mike had pointed out earlier, we have this trusted internal environment that makes up the EPC core of the infrastructure itself. But on each side of it, it's untrusted. So we need to have a way to be able to identify, authorize, authenticate professionals or support staff that have the right to come in and connect into this environment to provide any type of troubleshooting, any type of patching, any type of upgrades, things that need to be done. Conversely to that, we have the outbound connectivity, especially for monitoring and analytics. There are a number of different application providers. Again, Mike talked about the importance of some of that API connectivity in order to be able to get some of that information out. That can be going to some of the managed service providers, that can be going into other hosted applications, whether on-prem or even into the cloud. So we have to think about how we're getting that connection out of the actual core itself. And again, looking at some of the different deployment options, whether you're looking for flexibility, looking for scalability, being able to handle a multi-core environment, looking at where some of this information, especially if we have an active and a passive core versus two active environments, there are multiple things that we have to think about and how we're going to be able to address and handle some of the different types of secure remote access, as well as some of that data traffic moving to and from the environment itself. So always, the thing that we highly recommend, again, DMZs are kind of, been in place, have been around for quite a while now. I think, again, everybody has a DMZ in place, but a lot of times it's a matter of, okay, where are we going to be able to create within our Purdue model, again, the different levels and layers coming back through, how are we going to allow some of this communication to occur? And you'll see a lot of times you'll end up with this layer between some of the different levels that provide for proxy, that provide for a one-way data flow, that allow for the ability for users to connect into this shared plane that they can jump host over into the actual end devices or compute that we actually are housing the applications that are having the EPC and all those components that we had mentioned earlier. So again, a lot of these are, the systems down below do not have direct access into this trusted environment. They're not directly exposed, and we want to keep it that way, especially for the the security architecture. But being able to use a lot of these proxy servers, the jump hosts, any type of replication server, so that we're not actually connecting and dealing with the data or the repository on the actual device itself. These are all important components to consider, not only where the assets and the devices are going to sit within your data center, but also the infrastructure overall and how we're going to be able to access into it. The last thing I'll kind of talk about here is, looking at, again, depending upon if you're coming across the internet, depending upon if you're sitting on net in the actual environment itself, you're going to have different ways of being able to, again, identify, authenticate, authorize people, different support functions coming from the different types of areas. But having these different types of jump boxes, these different types of hosts, having the proper firewalls, your security, your access control, all of these things need to be enabled and thought through so that we can identify that data flow, we can identify the users, we can identify, even if we're having to do a secure file transfer because we need to upgrade or patch the system along the way, that we're thinking about all these things, that we have the identity management, we have those credentials, and that we can actually provide that audit trail of who's doing what wherever they may be, whether it's a third-party hosted managed service that's coming in to take care of this environment, or it's our own operators that are going into and connecting and providing any type of updates or configuration changes. All of these things need to kind of be thought of, and there are a number of different solutions out there that we're happy to kind of talk to you more about and what we recommend in this environment. Eric, was there anything that you wanted to kind of highlight here in kind of the importance of this secure remote access thought process and solutions that you're looking at?
Absolutely. First thing I would say is don't inherently trust the managed services provider, right? At the end of the day, you don't control their security. So while they might have to them a bulletproof process in place, right? Whether that's a jump host or their own radius server and those kind of things in their environment, you need to control all of that AAA type of functionality on your side once they cross into your network. Even to the point where we stood up our own radius server. So even though that technician from managed services or that support engineer has to hop through all those hoops on their side, once they hit our network, they've got to authenticate again and make sure that their account is listed in our radius server. Like Craig said, there are some commercial off-the-shelf products that you can purchase. I know a lot of people, have Citrix environments on their corporate side. So there are a lot of options, but my main point is make sure you insert yourself, into this flow somewhere. Don't just don't take them at their word, because at the end of the day, this is your network, and if something happens, it's under your watch.
You're responsible, exactly. Thanks, Eric. The last thing I want to cover is just really kind of around that zero trust architecture. Again, this has been mentioned many times. People go into this type of infrastructure looking to provide a zero trust methodology, and really kind of the point here is look for the frameworks that are published. Again, whether you're using MEF, whether you look at NIST, there are some commonalities between this on how this needs to be administered, what policies need to be set, where some of the different things need to be addressed. But again, each one of these kind of outlines things that need to be thought through. Access, identity, authorization, time-based, NTP, various different types of users, who are accessing what, do they have the right roles, permissions, the access control mechanisms. Again, these are different types of ways to really ensure that you're providing the least amount of authority or administration to some of these services, and gives you a framework to make sure that you're not missing anything, especially when it comes around the policy management for how you're going to administer and be able to support your infrastructure that's going in place. So again, just want to take a quick second to really kind of talk about some of these things. What are some of these components, and again, how this is actually being enabled to support a lot of the things that are going to be needed within your own infrastructure, within your own environment. Ensure that those are all being looked at and taken into account. So lastly, I wanted to give Eric the ability, we had the pleasure worldwide of working with Evergy, working with the security team on a number of various different components that we reviewed here. But Eric, any lessons learned, anything that you want our audience and those that are listening in to take away from this, and some of the things that you've kind of picked up along your way?
I've got quite a long list, but I know we only have about 11 minutes left, so I'll try to keep it brief. First thing is, you don't know what you don't know. In our organization, I was lucky to have spent a couple years at Sprint here when I moved to Kansas City. while they were upgrading their LTE network. So I got to learn some of this stuff years ago. Well, after I moved to the utility sector and started working for Evergy, I basically forgot all of that, right? Well, it wasn't until I was brought into this project that really had to start thinking about these types of things that you really, on a corporate, normal day-to-day security, role, you don't necessarily have to think about cellular network security, right? Mobile security. You're busy dealing with all the other stuff we deal with day-to-day. Depending on when your organization is engaged in the project, hopefully it's sooner than later, you really start to see that it can provide definitely a challenge. And there are areas I was talking about, the SIM profiles and your SIM strategies, all of these kind of things that we were not aware of at all until we started having continued conversations with Craig and team. And they brought up a lot of things that we didn't even know we needed to secure, right? So definitely get involved in the process, in the project early, engage security. As soon as you hear you want to build a PLTE network would be my suggestion. But then as well, don't be afraid to ask questions, right? Because there are things that you're not necessarily gonna know. So you're gonna have to leverage those relationships that you form to try to help make the best decision, right? And minimize risk for your company at the end of the day. But this is also an evolution for sure. I know that we're just standing up our production network at Evergy. We've got SIM cards coming. We're gonna have, probably a couple hundred, couple thousand, tens of thousands. Who knows in 3 to 5 years what our UE count will be, right, at Evergy. But just like any network, it's going to evolve. So the network a year from now, 2 years from now, 3 years from now might look completely different, right, from a security architecture standpoint. But if you make some decisions early, and if you go back to the slide that that Mike was showing, where you have, untrust, trust, and untrust. If you start to think about it and really utilize a zero trust methodology, it will help limit the risk tremendously. I'm continuing to learn things, every day on the LTE set. I was just on a troubleshooting call before this webinar, trying to help one of our radio guys figure out why a UE was not attaching to the network. So, I mean, this presents definitely challenges for your organization, but it also presents opportunities. We're thinking about possibly standing up an LTE dedicated team, right? Where you've got your radio guy, where you have your security guy, right? Just a core group that's solely focused on, the PLTE network. So these are kind of things that, depending on budget and depending on personnel, you might not necessarily have the capacity, at first to stand up. But these are definitely things that you need to think about, on your long-term, LTE roadmap. So I really appreciate everything that WWT has, taught us about cellular security, continues to teach us, but it really just comes down to don't be afraid to ask questions at the end of the day, because in security sometimes we're a little bit prescriptive where we think we know it all, and then you're presented a challenge of building out a network like this, and you find out, yeah, I don't quite know everything. So
no, Eric, definitely appreciate the thoughts and the really kind of, again, the relationship that we've kind of been able to build here, really over the past over a year now, as we kind of have, started this journey along with Evergy, and seeing how far you've come with where we started, a year ago to where we are today, and the fact that you're now moving things into production. So this has really been, a great conversation. Mike, definitely appreciate, the ability to kind of step through and look through some of these things, definitely with that security lens. I think this has been a great conversation. Bobby, I know we probably only have 5 minutes left, but any relevant, important questions that we need to, talk about or review here as we wrap things up?
Yeah, thank you. Well, you answered my questions because I had a long list, so I appreciate that. We have one, and it kind of edited also version of this question, but it's for clarification. And Mike, I think you can offer some clarification here. I'm going to read it straight out because these are letters I don't understand most of the time. You guys know that. Okay, here's the question from Jean-Louis. You mentioned Java card applets as potential security risk. Are you advising to use native OS instead? That's the first part of the question. And to clarify, GSMA mandates Java card support for consumer EUICCs and has security compliance processes related to EUICC OS and hardware. So can you just go through and jump on that and explain a little bit more, Mike, so we clarify what you were talking about there for the audience?
Sure, Bobby, thanks. So the point I was trying to make is that on the eSIM itself, there is Java code. And as Eric noted, whenever they heard Java, the first thing that they did, alarms went off and said, wait, we can't have that. Well, the fact of the matter is that there's no alternative,
Right.
or not that I'm aware of, there's not a good alternative. As a matter of fact, that EUICC is going to become your best friend, and it's going to have Java running on it. So think of that EUICC as being a very, very tiny computer that's running on that SIM card or embedded in your device. And it's isolated from the rest of the system. Now it talks to the rest of the system, but that card is in the future, especially as you deploy things like AMI 2.0, but it also is applicable to just routers and poles and that sort of thing. But that device is going to be communicating with the SIM administration system so that over the 15 to 20-year life, as you're making changes on your system, you do not want to drive out to, tens of thousands, hundreds of thousands, millions of devices to swap out SIM cards. And so to be able to handle that, you've got to effectively like a system on a chip that's running Java in there that will allow it to make those changes so that you can change the profile and change the characteristics of that. But the point there with Java is that from a security perspective, we're somewhat trained to say, wait a minute, I don't want that. Well, the fact is that you need it, you need to work with it. And so the way that you think about security relative to Java probably needs to change, through the course of time. So hopefully we didn't confuse the issue there. It's important. It's going to become your best friend. Just, think through how all that works. And by the way, that communication that I was referring to is identified in GSMA. I forgot the standard. It's like 2232, something like that. But anyway, there's some recent changes that have been published this year on how that's going to take place when you can't physically go out there and do anything with the device. Everything's going to have to be done over the air. Hopefully that explains that, Bobby.
Yeah, thank you for clarifying. We'll hold there. Obviously, I know you guys will be available for follow-up with members and attendees, but I'm going to turn it back to you guys for closing thoughts.
Yeah, again, I think what we've kind of highlighted here is that there are a number of various different types of, policies, procedures, things that need to be thought through. There is a methodology to the madness that we can actually help come in and really kind of set, many different types of departments, minds at ease on how we're able to really ensure the security and the protection of this new infrastructure that's coming in and providing, again, a new transport medium for utilities across private LTE.
Perfect. Thank you so much. With that, we are at the top of the hour. We will happily follow up, but I want to thank all of you for sharing your expertise, highly technical and expert webinar here. Thank you so much for being on the Utility Broadband Alliance webinar series. And we wish everyone a wonderful rest of your day. And you definitely showed us that cybersecurity does not have to be spooky here on Halloween. And I appreciate all of your time today. For UBBA, I'm Bobby Harris. I hope everyone has a great day. Thank you, everyone.